Okay, so there were several people who asked about the homework problem. This is the corner reflector problem. This is problem 13 in homework 12. And I think the hardest part of the problem is part A. Once you get part A, then the rest of the problem is fairly straightforward. The part B is fairly straightforward. So the hard part, most of the problem is not physics, unfortunately. Most of it is geometry. And so this is going to be something of a challenge in order to challenge you in your geometry skills. But there is a little bit of physics, so let's go through it. The bit of physics in this problem is the fact that I need this line and this line to be parallel when they come in. This is the idea of a diamond. The way diamonds work, in fact, is they work by total internal reflection. As the light comes in, it gets reflected off of the surfaces and comes out again. And this is why diamonds are actually graded on the quality of their cut as well as the quality of the diamond material inside it. So if you have a poorly cut diamond, it won't sparkle. Whereas if you have a well-cut diamond, it'll sparkle with brilliance because the light that goes in gets reflected back out into your eyes, and so it sparkles. That's the idea of a diamond. So we have these two lines that come in, light that comes in, gets reflected back out parallel, and here's the physics. Because they're reflecting off these two different surfaces, then I know that this surface has to reflect. The incident angle and the reflected angle have to be equal. And here, this one that we don't know, I'm going to call phi, and they have to be equal. Okay, and so we can write down our first equation. Given that these are parallel, and we don't necessarily know exactly how they're parallel, but we know that they must be parallel. And so we could have something like this, you know, something like that, or whatever. It doesn't really matter. This is the idea of a parallelogram. We know that 2 phi plus 2 theta must equal 180 degrees, or you can immediately get, if you divide the whole thing by 2, you get phi plus theta has to equal 90. Or in other words, these two angles that I've defined for my reflection, they have to be complementary angles. Okay, that's the first thing we know. Let's keep going though on our defining our angles. I'm just gonna, again, I'm gonna define some quantities. For example, I know I want to define this quantity here, and I'm going to call this quantity y. And I want to define this quantity, and I'm going to call this quantity x. And then I've got this angle left over, and that's going to be z. And what I know is, since that's a triangle, x plus y plus z is equal to 180 degrees. All right. 180 degrees. Now, that doesn't seem like it's getting us anywhere. Well, there are a couple of relationships. Remember, we want to get theta and alpha related to beta. So let's look at something else. Let's look at here. We know this line is defined by the normal to the surface. So we have an equation that says x plus phi has to equal 90 degrees. And we have another equation for the same idea. This line, y plus theta has to equal 90 degrees. And so if we solve these for x and y and plug them into our equations, here we go. If we solve these for x and y and plug them into this equation up here, x goes there, y goes there. What I'm going to get is I'm going to get an equation that says 90 minus phi plus 90 minus theta plus z equals 180 degrees. Or in other words, z is going to equal Z is going to equal phi plus theta, which we've already worked out what that has to be. That has to be 90 degrees. And so we've got these two conclusions that at least are worth knowing. And one thing this leads me to know is that my picture is a bit misleading. These lines here should be right angles, not the way that they're drawn. So that's kind of nice to know. My picture is misleading me. But from here on, and now the rest is, again, like I said, geometry. We've worked out, we're going to have to do some more defining angles. Because what I want to do is I want to notice that there's a triangle here that includes Z and probably includes beta, and I can probably include alpha in there as well. And so once I get this done, I can solve my problem. Okay, so let's solve that triangle. I'm going to define some angles here. Of course, this angle here is already defined. That's Z. Let's define this other angle. Sorry. This one is already defined. That's Z. If we define this other angle, I don't know, let's call it, gee whiz, I'm running out of letters, capital A. And let's call this one capital B. I know that looks terrible. Well, what do we know? Let's think about this. I can see another triangle. First of all, B is easy. B is beta minus 90 degrees. That's B. A is a little bit trickier, but if I can recognize that this is a triangle here, and this one is 90 degrees, then I can get A's relation to alpha, because A is going to be 90 minus alpha. 90 degrees minus alpha. Okay. And from there now it's just added up. A plus B plus Z equals 180 degrees. Okay, so let's write that out. A plus B plus Z equals 180 degrees. That's just a triangle. You know, the rule about angles of triangles. And so now I can plug in my numbers. I get 90 degrees minus alpha plus beta minus 90 degrees plus Z, which is also 90 degrees, plus 90 degrees, which is Z, equals 180 degrees. That looks like a bunch of 90s, but we can cross some of them out. You know, this one can cross out with that. That 90 is going to subtract off here, and we're going to have 90 degrees left over there. And what I'm left with, if I solve this now for beta, I get beta is equal to 90 plus alpha. And there's my definition. That defines my beta. So as long as beta, and remember, beta is defined from the same plane as alpha. So alpha is defined, and that defines one cut surface. And then we come up from the same plane to an angle beta. And as long as 90 plus alpha is satisfied, then I'm guaranteed that Z is going to be at right angles, and the surface of my planes will be at right angles, and so then my corner reflector actually works. So then any light that comes in this way will get reflected out that way, so that these two rays are parallel. So that's the way you solve this problem. Like I said, other than the small bit about the reflection angles, given that these must be equal and these must be the same. Other than that little application of the law of reflections, most of this problem is geometry. It's part B then that you get into the more interesting bits of physics, asking you, okay, then what alpha has to be to have total internal reflection. Okay. Anyway, hopefully that helps you. If you have any questions, you can talk to me or email me.